If you're a regular viewer of my videos, you may recall that the original reason that I built this steady rest was that I was working on this long turning demonstration, and we'll say some unforeseen circumstances caused me to need to blend this end part here with the already turned section. But when I got it in place with the tailstock center, I was getting a few thousandths of run out, and that wouldn't work trying to blend this part together. I need it concentric with the already turned part within a few tenths. So that was the driving force behind the steady rest, and now we've got it here and I'm ready to turn down this section. So I've set up the workpiece in the 4-jaw chuck, and I've used the standard 4-jaw centering technique to center this section, and I've got that to under a tenth, or about a tenth maybe, but it's pretty close in any case. And then we'll check this end here with the steady rest. I added some brass sleeves on the ends of the screws just so that we'd have a softer metal in contact with the workpiece, and then some locking nuts on the adjusting screws. Alright, we'll bring the dial indicator down in contact. And right now, as you can see, it's out by about a half a thousandth, which isn't terrible, but it's not good enough for this job. So let me see if I can tweak these adjusting screws a little bit and get that any closer. So I'm going to loosen the lock nut, and it's starting to squeak. So I've been working with this for a half an hour or so, and I've discovered already a few embellishments I'd like to make to the steady rest. And one is these locking nuts I think are just too coarse to achieve fine adjustments of less than a thousandth. I can probably get it within a thousandth without too much trouble, but when you try to center it down to a tenth or a few tenths, between the male and the female screw threads probably has more than a few tenths of clearance, so as you adjust these locking nuts it throws it off. But as I very gently tweak this locking screw up here, you can see I'm now down to about a tenth, so let me just try to lock that one in. And that threw it off just by a little bit, not a lot, but so we're still within about 3/10. But anyway, bottom line is tweaking these screws and locking nuts is not very convenient. It takes a lot of time, and it's kind of annoying because you can't get it just where you want it. I already have some plans in mind for the Mark II version. One is I want to replace these screw heads here with some brass knurled knobs. That will make it more comfortable to adjust. The sharp corners on these screw heads are not comfortable. Secondly, I want to either replace or augment these locking nuts with another locking mechanism that gives me finer control. And third, just as a routine thing I like to do, I want to get rid of these sharp corners here. I don't like having sharp corners on anything that's near the work area, so I'm just going to take these over to the belt sander and round them off some. Okay, well, after some tweaking, I think I've got it pretty close now. It's down to about a tenth of a thousandth or less. I think that's good enough to try a skimming cut on the end here, and we'll see what happens. Alright, well, here's the setup. We're going to take a real light skimming cut, cutting towards the headstock, and let's see what happens. Well, it cut the section that it was intended to cut, but not the section that's adjacent to it. So let's see what the diameters are now. The outer end there is 1.371, and the previously turned section is 1.363. So we need to remove 8 thousandths. We need to reduce the diameter by 8 thousandths. So I'm going to feed in by 4 thousandths. Took one more skimming pass of just about a half a thousandth, and it feels really well blended now. Before I took that cut, I could feel a little ridge line just barely with my fingertips, and now I can't. So I think we're really very close. I'm measuring 1.363 on both sections now, so I'm satisfied with that result. As a double check, I want to run the indicator across both parts here, because it's possible that even though the diameters match, that they aren't concentric with each other or with the center line of the lathe. So let's see how that looks. So that's the newly turned section. It's got a little jump there of about 3/10 it looks like, so I don't know what that's from. But let's go over to the part that was previously turned. And there is maybe a little jump there, but it's not more than about 1/10 in any case, so we're well under 1,000th. So you can see as we go from the far end out here and all the way in to here, you know, we're well under 1,000th, so good enough. Okay, after a long diversion to make the field expedient steady rest, we're now back to the original problem, which was bringing this piece back to the drawing specifications. So we need to end up with this center section 6 inches long, and then this end part 1/2 inch long. So let's take some measurements and see what we have to work with. I've been using my 6-inch digital caliper all along, and it turns out I use it for probably 90% of my work. Sometimes I have to go to a micrometer, or in this case I need a longer digital caliper. A few years back I bought this 8-inch caliper, which is from Harbor Freight and very similar to the 6-inch one, except that it's longer obviously, but it also has longer jaws so I can reach over the steady rest here. And I'm going to take a few measurements because it's a little hard to get an accurate measurement when you're holding it like this. If you have it tilted a little this way or that way, it can throw the reading off. So I'll take about 5 measurements and then we'll average them. Here are my 5 measurements, and you can see they range from 6.527 down to 6.523, and it's just coincidental, or I think it is, that they happen to be in descending order. From this I can say it's about 6.525, and that's close enough for what we need right now. We need to bring it down to 6.500, so what I'm going to do is take about 20 thousandths off at the end, and then we'll check again and make our final adjustments. So I made the measurement from this shoulder up to this end. So the overall length when we're done will be 7 inches, but the section that I measured from this shoulder to the end will be 6.5. Before we start cutting, let's check the run out again. So I'll check it here near the chuck. It still looks pretty good. It's around 1/10, which is good enough. Let's check down here while we'll be doing the cutting. By about 5/10, maybe 4/10, somewhere around there. After a little bit of tweaking of the 3 adjusting screws, I've got it down to about 1/10, maybe even a little less, so that should be good enough. I have the tip of the indicator adjusted into the conical hole there, and let me use the fine adjustment on the indicator now, and I'll bring that tip down into contact with the work surface. You can see there's about 2 thousandths of run out. So we know that this surface here is true to within about 1/10, so we can't use that hole to achieve the results that we want. And that's what started the whole steady rest project. I'm going to put a little fresh oil here on these steady rest surfaces, but as you can see there's a very fine paste of minute brass filings that's been worn away, but the surface of the steel bar is slightly abrasive because there's a very fine thread to it almost from the cutting tool. You can tell if you run your fingertip across it. So it's gradually grinding down these brass tips, although very slowly. But one benefit of that is they actually are conforming more and more closely to the curvature of the workpiece as they wear. So I'll be feeding in with the compound feed, and the compound is parallel with the ways, so I can read the depth directly off of the compound hand wheel calibrated dial. So I've set the hand wheel dial to 0. Now touch off my tool against the face of the workpiece. Then I'll lock the carriage down. And ultimately I want to go in about 20 thousandths, but I'm going to take several light cuts. I want to take light facing cuts because I don't want to apply very much pressure that would shift the work in the steady rest. I think I'll start with just taking off about 5 thousandths. I think I have 900 RPM, and that's about 10 o'clock on the dial. That's a pretty light cut. I'm going to put a little Cap Magic. This is Cap Magic regular, as I call it, not the aluminum, but we're cutting steel, of course. One disadvantage is, as you can see, it produces a lot of smoke. I'm going to go in another 5 thousandths, then we'll take a measurement. .506. Let's try take another one here. About 6.507. .507. So we'll assume it's 6.507. I think I'll go ahead and turn down this part now to form that shoulder, and then we'll bring it to final length after we've got a check on that. So I'm going to zero this dial now, and then I'm going to cut in, then I'll cut in just a little under 0.500, maybe 0.495, and then we'll form our final shoulder after we get most of the cutting done. I fed the tool in 0.500 using the compound hand wheel. I'm just going to make a light scribe mark there as a reference. Now I'm going to feed the cross slide in 20 thousandths, and that will remove 40. Now we'll feed in with the compound. Trying to use a two-hand feed here, but it's difficult. And I'm going to stop short of my reference line there. I'll feed in another 20. I've got the tack set at about 900 RPM. I decided to stop and clean some of the chips out of the way here. Got a lot of chip buildup, and I want to take a measurement. Okay, we're at about 1.054, and our target diameter is 1.000. So I'm going to go in now and clean up this face. As you can see, when you take a succession of cuts with the tool angled slightly like this, it leaves sort of a sloping face on here, which of course is not what we want. So I'm going to come in and make a few facing cuts to clean that up. Then we'll bring the shoulder to the final length and final diameter. As you can see, there's a pretty good buildup of spirals of steel down here. I don't like to let them build up too much so they can get snagged on the work and thrown around and create a hazard and possibly also mess up the work. was hearing some screeching from the brass here, and it gave me the impression that the steady rest may have loosened up some during the cutting, so I thought I'd better check that. And you can see our runout has increased to about 1/1000th, so I'm going to readjust the steady rest to reduce that back down to 1/10 if I can get it there. I decided I'd better check down here close to the chuck too and see how that looks, and we have gotten a little bit more runout down there, but not much. But I may tweak that a bit too. Did some work off camera to bring it to the final dimension. It was just too awkward trying to work to close tolerances with the camera in the way and the distractions of doing the video. It looks good within the degree to which I can measure it in its current configuration, but let's take it over to the layout table and see how it looks. This is the end that was clamped in the 4-jaw chuck, so it has some marks from that. If I had wanted to prevent that, I could have used some copper coverings on the chuck jaws. And I probably should have, but you know, I wanted to get the job done. But here's the end I just finished. Doesn't look too bad. And you can, I don't know that you can even tell where I blended those two surfaces together. I can't feel it with my fingers, so I know it's pretty well blended. I've zeroed the indicator to the surface plate. Let's take our overall length measurement and see how that looks. That should be 7.000 at the one end on the surface plate, the other end up here, and there's our overall length measurement. So about 3.5 thousandths under. Let's measure up to this shoulder here. That should be a 1/2 inch shorter. That should be 6.500, and it is 6.497. Flipped it over now, we'll measure to the opposite shoulder. And it is 6.499. So that's pretty close. That's maybe 1/1000th under. I'm going to set this shoulder on 2 1-2-3 blocks so we can just measure this center section. So I'll zero the indicator to the top of the 1-2-3 block, and then we'll measure up to this shoulder, and it looks like it's 6.001, so we're maybe 1/1000th over there. Let's check this diameter now. 996, that looks like it's about 4 thousandths under. That was the first one I did. Yeah, about 996. And let's check the opposite end. And it is 1.001. Let's try again. I'll squeeze it a little harder. Now we're 1.000 and a half. I'll check it with this Mitutoyo micrometer here. See if I can get an accurate reading with that. I don't use micrometers a whole lot, so my skills are not the best. 999.6. That one's pretty darn close, within within a 1/2 thou maybe. This mid part here should be 1.360, and that looks very close, maybe 1/1000th over. So I'm not going to complain about that. I'm sure there's some variation from one end to the other, so let's see if we can verify that. 1.359 looks like down at the other end, and it is about 1.363 it looks like. Yeah, so seeing about 4 thousandths from end to end, and I think that's inherent in the lathe or possibly the tailstock, I'm not sure, so maybe I'll do some more analysis on that another day. Let's check the concentricity of these two ends. So I've got a 246 block here just to act as a mass to keep everything lined up. And then I've got the indicator base clamped down to the block. And that helps the magnetic force from the indicator base helps hold these two V blocks up tight against there. Now I'm just going to rotate this bar by hand here and watch the indicator. This indicator is measuring in 10 thousandths of an inch, so between the digits is 1/1000th, and between the lines is 1/10,000th, so it has less than 1,000th of run out. Okay, it's at the 2 now. That's about the low point. Let's go all the way around here. So looks like about 8/10 maybe. Let's check the other end. I turned it around once, so this looks like the low spot here on the 3. I'm rotating it around. There's our high spot, so it's about 6/10. So that's only 3/10 per side, right? Not too bad. So 6/10 is the total indicated run out, maybe 7/10. So the off center per side is maybe 3/10. Not too bad. So as I like to say, for an inexpensive import lathe and a non-professional operator, all in all, it's acceptable.